Here is a combined summary of the 2 pages. The paper proposes a novel transfer learning approach, dynamic visual prompting, DVP, to adapt pre-trained language models, PLMs, to vision language, VL, tasks. The motivation is to avoid building heavy fusion networks and utilize the context reasoning ability of PLMs. Current PLMs require a deep multimodal branch for VL reasoning, resulting in excessive computation and memory overhead. Visual prompting is a feasible way to adapt PLMs to VL tasks, but it greatly increases computation complexity. DVP addresses these shortcomings by deploying a cross-attention module to obtain task-related and compact visual prompt tokens, reducing the input length of PLMs. A reinforcement learning-based search algorithm is used to automatically merge DVP with PLMs for different VL tasks. DVP is combined with the adapter approach to keep most parameters of PLMs intact during adaptation, enabling a quick shift between single and multimodal tasks. The authors apply DVP to 2 representative PLMs, BERT and T5, and a recent large language model called Llama, on a set of VL reasoning benchmarks, including VQA 2.0, GQA, SNLIVE, and ScienceQA. The experimental results show that DVP can save up to 80% computation while improving performance significantly, e.g., plus 2.28% accuracy on VQA 2.0 for BERT. When combined with the adapter approach, DVP can maintain the overall performance of PLMs on these benchmarks, updating only about 5.0%–6.0% of the model parameters for VL adaptations. The contributions of this paper are threefold: directly adapting PLMs to VL tasks via inserting visual prompt tokens, proposing DVP for efficient PLM adaptation, and achieving competitive performance on multiple benchmarks while saving parameters and training overhead substantially. The paper also discusses related work in vision language pre-training, prompt tuning, and soft prompting, highlighting the novelty of the proposed approach. The research proposes a novel approach called dynamic visual prompting, DVP, to efficiently adapt language models for visual language tasks. This involves using a lightweight network to generate compact visual prompts, reducing computational burdens and redundancy. The method adopts cross-modal attention to dynamically generate visual prompts relevant to the input text and image. For efficient placement of DVP, a K-armed bandit-based automatic prompt placement algorithm, KABAPP, is proposed to automatically find the optimal insertion layer for DVP on different PLMs. This algorithm models the search process as a karmed bandit problem and updates preferences based on rewards from validation. The combination of DVP with adapter, a parameter-efficient transfer learning approach, further enhances performance and efficiency. Experiments on the VQA 2.0 dataset demonstrate the effectiveness of this approach, achieving optimal performance with reduced computational overhead. The research paper discusses the dynamic visual prompting, DVP, method for adapting pre-trained language models, PLMs, to visual language, VL, tasks. It proposes a novel algorithm, KABAPP, for automatically finding the optimal insertion layer for DVP. The paper presents extensive experimental results on various benchmarks, including VQA 2.0, GQA, SNLIVE, and ScienceQA, comparing DVP with common visual prompting solutions, manual search, and other VL pre-trained models. The results show that DVP can achieve competitive performance with fewer computational resources, especially when combined with adapters. The paper highlights the importance of prompt placement and the effectiveness of KABAPP in finding the optimal insertion layer for DVP. It also demonstrates the generalization ability of DVP to other language models, such as Llama. Overall, the research contributes significantly to the field of VL tasks and the adaptation of PLMs to these tasks. The research paper discusses the exploration of pre-trained language models, PLMs, as standalone models for vision language, VL, tasks. It proposes a novel transfer learning method, dynamic visual prompt, DVP, which adapts PLMs on VL tasks by generating text-related and compact visual prompts through a cross-modal attention layer. Additionally, the paper introduces a reinforcement learning-based search algorithm, K-armed bandit-based automatic prompt placement, KABAPP, to automatically find the optimal placement of DVP. The method is tested and compared with other prompting solutions and existing VLP models, showing superior efficiency and competitive performance. The paper also highlights the efficiency of combining DVP with the adapter approach to reduce the scale of updated parameters. The authors conclude that DVP is an affordable way for quick PLM adaptation, making it a valuable contribution to the field of VL tasks. The research paper discusses various methods in natural language processing, focusing on prompting techniques for pre-training and fine-tuning language models. It surveys several approaches, including p-tuning v2, which shows comparable performance to fine-tuning across scales and tasks. The paper also explores the limits of transfer learning with a unified text-to-text transformer. Additionally, it delves into efficient vision language instruction tuning for large language models and the benefits of using CLIP for vision and language tasks. The authors also discuss the concept of dynamic token sparsification for efficient vision transformers and the use of thought chains for science question answering. Furthermore, the paper touches on multimodal few-shot learning with frozen language models and the application of stacked attention networks for image question answering. It concludes by highlighting the importance of understanding the limitations and assumptions of these methods for future work.